Hello everybody, my name is Kai Gertling, I'm from Verisurf. I'm here at the German Shining 3D headquarters to have a chance to try the new FreeScan UE 11 together with a typical demo part what we are using. It's a sheet metal part what we are going to use later on for inspection. The good positive thing on that special part is that we can test and check a lot of different alignments, what is typically defined to the dedicated applications and the different markets. Okay, I'm going to start now. I take the scanner and will start with a preview and check if everything is fine. And then I will start the scan. The positive thing is that the scanner is really very light in the hand. It's a good feeling. And it's also very, very quick and fast to get a high resolution point cloud, what we can use later on for inspection. Don't worry about my position because it's linked also to the video. You know, normally you can use here also a kind of turntable to be more effective in ergonomic. And it looks like that I'm almost ready. The data looks almost good. Maybe I need to make some little scans more. Check. It's the first time when I use this system, so maybe I'm not really very perfect, but I think the good thing is to show how easy it is to handle. Even for a non-trained guy like me. And the positive good thing is also I see directly on the scanner with this light here the distances if I'm right or not. Because if I always need to look here, you know, it's also for the ergonomic not very helpful. For me, as a non-specialist, the data looks good. I need to check with our Shining team, and later on you will see in an additional video inspection and all what we do with this part. Thanks for your attention.
In this exercise, we're going to take this mesh and align it to the CAD model based on a typical RPS style alignment popular in Europe. So the RPS alignment we're going to use is this hole here, fixed in X, Y, Z, this slot fixed in Y, Z, and we'll have a surface point here to control Z based on the figures supplied. So first of all, when you bring a mesh into Verisurf, Verisurf treats the mesh as nominal data. We can tell this by the little green coloured icon here. So we need to make the mesh behave as measured data. Okay, the way to do this is we select it, we right mouse, use as measured. See there, the icon changes. Okay. So the first thing we're going to do is we're going to create some datums for the RPS alignment. So we'll go into the measure module, create target, select the hole there, the slot, then a surface point somewhere around here. escape. Now we can look at the targets. So we double click the first one. Okay, it's fixed in X, Y and Z. We want the point, and it's a 2D circle. We go OK. Target 2. This is the slot here, and it's fixed in Y and Z. And again we want a point, and it's a 2D slot. The third one was this one here for the Z value, target 3. So we untick the X, untick Y, we leave the Z, but we need to put in the correct figures that were supplied. It was -45, 115, and 0. Okay. The target type is a surface, and the way it's measured is a point. Okay, so those are the datum structure created, and now we need to create a plan to do the alignment. So we'll go to Automate. Should we select the mesh first? Automate. Go with this one. Create new plan. This is a default name. You can call it anything. I'm going to call it alignment. Now we need to give it some commands to do the alignment. So here, command, we click it, double click, we'll choose global register, and we'll select the mesh. So global register takes the scan. We can't do a best fit just yet. We need to get the mesh quite close to the CAD model. So global register will take the mesh and fit it very, very close to the CAD model. Then we'll give it another command. Choose best fit with options, and again we choose the scan. So in effect we've moved the mesh to the CAD model, then we've done a surface best fit. Now we're going to give it another command to auto align, and this will do the RPS alignment. So now that's the plan created for the alignment. Now we'll create a plan to do the extraction of these features. Okay, so let me hide the mesh for a second. Turn it off. Get a nice view here. Create a new plan. I'll call it extraction. Okay, we need to add some CAD features inside this plan to do the extraction. There's a couple of ways we can do it. We can either, in this white space, we can right mouse, add from CAD, and then force a particular feature type. Or we can go to this one, add feature from CAD, and if we use this one, Verisurf will decide the feature type. Okay, so there's a quick way, we don't need to click each one. We can use the quick mask. So if I select arc entities, curves, press this. There. It added the ellipse, the two slots and the circles. Okay, now we need to tell Verisurf how to do the extraction of these. So we select them, right mouse, change extract setting. Okay. And I'm going to use the CAD zone. I'm telling it to look 1 millimeter from the CAD zone. You can use the feature zone because we have CAD features here, but I'm going to use the CAD zone. So OK to this. So now we'll position some balloons out where we want these. So we select, then we use the move. Bring them where we want them. Now we can decide what information we want to report. I just want to report a position for all of these. So we can do it here by selecting what we want to report. I'm going to go into the report manager. So I'm going to pick circle 1. Mine's already set for just the position. Yours might come in with XYZ selected, diameter selected. So just untick the one you want. Then you can set the tolerance here. Okay. don't want X, Y, Z, the ellipse. I just want position. Got a tolerance of 0.5 millimeter, that's fine. So the slot, I don't want X, Y, Z. Pick this up a bit. I don't want the length and width, but I do want the position for width and the position for length. And the same again. Length and width. Position, width, position, length. So if we go on them now. There we go. So that's what we're going to report. Okay. We need to clear these. This is nominal measurements. If we try and run it, nothing will happen. So we need to clear this. So that's ready now. So now we can go to the plan. Select the alignment, run. Do the best fit. We'll leave these as unticked. We'll leave it set at the default settings and just fit. Say OK to this. Now there's the RPS alignment. Move this out of the way. So there you can see it's nicely aligned. So there's the X, Y, Z, the Y, Z, and the Z. So now it's aligned to the RPS alignment. Before we run the inspection, I'd like to add a screenshot here, so we can add a screenshot to the report. So go to Automate. Select all balloons, go this one, screenshot, just click in the white space on the graphics and press enter. So there it's added a screenshot, so when we run the plan we have a report. So now we can run the plan offline. Now it's populating the results in the auto inspect dialog. The flash at the end was the screenshot. Here's the screenshot. So we'll get the results, we get a screenshot. So that was very quickly how to register a mesh, run an alignment, an RPS alignment on the mesh, and report, extract measured features. It's also possible, if you have multiple parts, you could bring in multiple meshes, and it's possible to register them automatically. Then you can select each mesh and run the extraction to get the measured data. In this video we are going to look at the registration of a mesh captured by a hand scanner to a CAD model. So first of all we'll import the CAD file, so file open. Okay. There it is there, but I'll just go through the process. Browse, choose the file type, so I've got a step. There it is, there's a step file, open. Okay, there's your CAD file. So now we need to bring in the mesh. So on the reverse tab, this little icon here, import cloud or mesh. Okay, there it is. It's very important that this must be selected for the type that it is. So this is a STL, so we must select STL. There's various formats we can import. Okay, so it would work. It would still work if it's on all files and you click this STL open, but it will bring it in wrong. There'll be faces everywhere. You won't be able to do anything with it. So you must force it to the particular type. So select the mesh, open. One of the things that Verisurf does when it imports a mesh, it treats the mesh as nominal data, but our nominal is the CAD model. Okay, we can tell it's nominal by this little green symbol here. So it's very easy. We want to make this measured data so we can compare it and align it to this CAD. So we click on it, right mouse, use as measured. See this icon changes color? So now Verisurf treats the mesh as measured data. Okay, that's one of the most important things. Okay, with just a quick talk on the mesh while we're here. If you right mouse click under reverse, mesh utilities, we have quite a few mesh editing options now. Power mesh, we've had this for the last version. This is a one-click operation to clean, refine, smooth and give you back a watertight mesh in one operation. Stitch mesh, you can cut away a piece of a mesh, work on it, do things, and you can stitch it back within microns. Quad mesh, this will give you back a quadrilateral mesh. It's really good for, how can I say it, if you've got a mesh that isn't great, if you run quad mesh on it, it will improve it. Okay, it's good for 3D printing as well. Optimized mesh, this is a really good one. So if you think of a mesh that has lots of planar surfaces, okay, it will reduce the data, the triangles for the planar surfaces, but increase it where there's curvature. Okay, another good one for 3D printing as well, and it also drastically reduces the file size. Okay, segment mesh, this is a new one. We'll talk about this once 2021 is released. So what we'll do now is we'll hide this for a second. So we want to align the mesh to this CAD. Okay, there's a couple of ways we can do it. We can do it manually, so we could take the mesh, we can do things like tools, global register. So we have to get, before we do a surface fit or a different type of alignment, we have to get the mesh somewhere near. Okay, we couldn't do a surface fit like this, it's too far away. So what global register does, Verisurf takes the three furthest parts of the CAD and it tries to match them to the three furthest points of the mesh. Okay, and it works very well. But it's important to understand that if you use global register, you need to scan the full object, obviously, because Verisurf is going to take the three furthest points of the CAD and the three furthest points of the mesh. So if you imagine you only scanned half of this, it probably wouldn't work very well. So you'd have to use things like endpoint alignment, where you click on the CAD, click on the mesh, click on the CAD, click on the mesh, and you could align it that way. But global register works very well if you scan the whole object. Okay, then you could go to analysis and you could do a best fit on there. We can also do it in a plan. Okay, so that's what I'm going to do in a second. But we'll also set it so we can do some feature extraction as well. Okay, so we can do some inspection. So at the moment, this is just a surface model. There's no CAD features, it's all surfaces. So we want to add maybe some CAD features to this. So we've got tools, auto hole. If you select this one, select matching diameters. If you've got lots of holes of the same size and you click inside, it will generate a CAD feature for the rest of the holes. So if I go I just want the circle, I don't want a center point, I don't want an axis. Let's go here, scroll down. See the shading change for there? There. Okay, so that's take escape just to take out the shading. So there it's found the circle there. So if we go again, auto hole axis, this position, top, middle, bottom, you might have to play around a little bit. I know from just looking at this. There, if we pick the bottom, it's on the top of this. Okay, take escape to take the shading away, the selection. Okay, so let's create an inspection plan to automatically extract some features. So if we go into automate, this is where we create the plans. Okay, get a nice view there. So we need to create a plan. So go here, plan. This is a default name. You can call it anything you want. So let's call this register. Okay, so we know what it is when we've got some plans. You might have a few plans, and it's good to give them a name so you know which is which. So now we need to give it a command. So let me select the mesh first. Okay, so we give it a command here. We double click and we choose the command. So we want a global register. and then the selection is the mesh. Now we're going to give it another command, and double click, and we're going to do best fit with options. Select the mesh. Okay, so that there is the plan created to do the registration. Okay, so let's hide the mesh for now. Go back into Automate. Let's create another plan for the inspection. So I'll give it a name, and you can call it anything. Inspection. Okay. So we need to add some features into here, some CAD features, so that Verisurf can extract the measured features from these nominals. There's two ways to do it. We can, in the white space, we can right mouse, add from CAD, and you can force a particular feature type. Okay. Or you can use this one, add feature from CAD, and Verisurf will decide the feature type. Okay, so if I go here, this circle, see the shading change to the wireframe there? I'll click on this sphere and then press enter. So let's add some features. So if I click on the plus, there, enter. So there's the circle and the sphere added to the inspection plan. Okay, we need to now tell Verisurf how to extract these. So if I select them, okay, right mouse, change extract settings. Okay, so you can use the CAD zone or the feature zone. Okay, so let's. Sometimes I use the feature zone by itself to tighten it right down. So let's try that. Okay, it's very important you must have a negative sign in the lower box for the height and the radial box for the minus size. You must have a negative sign, else it won't work. Okay, so I've got it set at plus or minus 0.5 millimeter for radial and height. So say OK to that. And let's move these balloons around so it makes sense. We'll open up this window. So we'll go move. So we can drag these around. Let's put this over here. This here. Okay. So for the circles, it probably doesn't make sense to. So for the circles, it probably doesn't make sense to report the Z. Okay. So select those two. General, drag this up. If I click on the Z, there you can see it's taken the information off for the Z value. The sphere, what we got for that? X, Y, Z, diameter, sphericity, position. We'll leave that as it is. Okay. We can add a view to this. Put that at the start. Okay, select these again. And we can do a report as well. So with those there, go screenshot, click in the white space, enter. Now we have to, these are nominal values here, okay, so we need to get rid of those. If we try to run it, nothing will happen. So we go clear all. So now we're ready to run the inspection, okay. But first of all we need to align and then we can run the inspection. So if we change the plan to register and then we run it. And you need to run it in mouse mode. So we look at measure, device manager. I've got mouse mode active. You can activate it here. Okay. So if I close this box, I'm not stopping it. I'm just closing the box. So if I go now here, run. Take a second or two. So the global register's got it somewhere very close. So now we'll run the best fit. So we don't tick any of these. Okay. This one, actually, if it's a very good scanner, which yours is, you could use this one. Okay. This one, don't use this one. This might be going away in the near future. This is for when the mesh isn't very close, but we use global register now. So we'll just leave those unticked. We'll do maximum iterations of 100. We use 1,000 points. Okay. 10,000 I got there. Let's put it down to 1,000. 1000 points, and then fit. Okay, we'll say OK to that. So now we're ready to run the inspection plan. Go inspection, and you can take the mesh off if you like. You don't need to have it on, so you can either leave it or take it off. Go view. This we do the inspection. We run it offline because we already have the data and it's aligned, and we know the nominals. We run it offline. Okay, so we run here. Okay, so it didn't do the sphere, so we need to change a setting for the sphere. Oh, it's done it. There we go. It just took a little while longer. Okay, so it's created there the measured features from the mesh using these nominal values here with the settings that we applied. So if we go right mouse again, so we told it to look 0.5 millimeter above and below the nominal feature zone, and radially 0.5 millimeter inside and outside. Okay, so there we are. So we can show report. Here's the report. So you get the information there, the text information, and the screenshot. Okay. Color map. If you want a color map, take the mesh, analysis, go color map, analyze. It depends on what your settings are. If you go here, projection settings, you'll either have been using discrete colors with deviations on, or color map. So there's the settings for the analysis. So I've got it set at plus or minus 0.5 millimeter there. You can change it, whatever. Red is above, blue below. If you've got a default installation, you've never used this, it will probably be like this. In the US, any excess plus material is blue, undersize is red. It's completely the opposite in reverse. So if you set it here from where I've done in preferences, it will stay like this. So if we come down, show deviation, I don't want that on. Come down, I don't want any points or lines. I just want a CAD mesh, a color map. So I say OK. So now if we go here, analyze. Take a second or two. And there's the color map. Okay, and you can put balloon text on this. So if we have it selected, analysis, go right mouse, balloons, auto add balloon, and you can display any of this information. For something like this, probably just the deviation. So click on it and drag. Okay. Also, you have this message as well. So the plus and minus, you can increase or decrease using the keypad on your laptop. So next to the number pad, you've got the plus and minus, so you can increase or decrease. Okay, so nice and easy. Just click and drag it to where you want. Okay, you can save that and add it to a screenshot as well for the report. Okay. So that was registration of a mesh, of a scan with a handheld scanner, automatically meshed, automatically registered, sorry, and then analysis in a plan as well, and a color map. Okay.